back to the channel, everyone. Today, I'm going to help you understand one of the most misunderstood products out there. Palantir's Apollo is not just a CI/CD build system. It is going to enable the future of cloud computing, which in my opinion is sky compute. Apollo lets you manage any container workload on any cloud provider and on-prem and on private networks. Understanding this product is the key to understanding Palantir's true value in the future. So get ready, people, with an interview with Greg DeArment, Chief Architect of Apollo.
Cool.
We're live. Let's do it. Thank you both, by the way, for giving me the opportunity to do this interview. I'm super stoked. And as you know, like I've been super into Apollo. I guess one of those products that I've spent quite a bit of time trying to learn about. And it's definitely a product like people don't know a lot about it. I get a ton of questions from people, and they're like, "What is Apollo?" Like I've heard some really interesting theories about what it is. There's a few people on Reddit that kind of have a good idea maybe of like what Apollo does and what it is, but I think it's totally misunderstood, even by me for a long time. Like I was lucky to meet Isabel, and we did a Brainly roundtable, and I kind of got like an idea of what was going on. But in any case, can you tell me a little bit about your background at Palantir and like how'd you start working on this product, and maybe a little bit about what the inspiration for Apollo was?
Yeah, definitely. So I joined Palantir back in August 2011. It's a little more than 10 years ago. I spent the first couple years as a forward deployed engineer in the commercial space. We like just started our commercial business. I worked with a couple of our early commercial customers, and I did that for about 3 years. The customer I worked with, like sort of through happenstance, I was responsible for like deploying what at the time was like the like alpha or beta versions of like the next generation of backend tech we were building. And like it was just like really painful to do. I did that over the course of like several months. And like at the end of it, I came out of it and I was like helping another team at Palantir basically to do a lot of the same stuff I just did, and like really form like ingrained in my mind. It's like, wow, like if we're going to be successful as a business, like deploying software cannot be this hard, or else this is never going to work. And
Right.
so coming out of that, we basically formed a bunch of opinions and ideas around like what we wanted software deployment and management at Palantir to be. And then basically pitched it to some of our directors at the time, and they're like, "Yeah, here's the team. Let's try to go build it." And so that's basically where we started. So we got started basically January or February of 2015, and then it's been an evolution. It's like not something you build overnight. But we've been working on it basically since 2015.
Nice. And then maybe in as few words as possible. I know this is the hard part, but like in as few words as possible for my audience, can you tell us what Apollo is? Like, what does it do and what is it
Yeah.
for?
Yeah. So Apollo is a platform for doing production software management at scale across heterogeneous like environments. So like a way of managing software platforms that you need to deploy to a bunch of different places, but have a way of managing them and deploying them as if they were SaaS.
Nice. Love it. And then if we think about like software deployment, sort of the state of the union today in the industry, like how would it compare to the way we've typically approached it in platforms like say Jenkins or TeamCity or AWS Code Build or any one of these other various tools out there? How would you compare them?
Yeah, I'm not familiar with TeamCity, but certainly Jenkins. So like I think a lot of like the evolution of software development and then continuous integration of Palantir. So like it used to be very much like Jenkins. You write a bunch of bash scripts, throw them in
Yep.
Jenkins, and then like suffer under the mess you just created. And then
Love
I don't
it.
know, maybe I don't know what it was like 7, 8 years ago. I think the sort of like continuous integration stuff out there had sort of evolved beyond Jenkins to this idea of like, well, declarative pipelines. Instead of like bash scripts running all over the place, I'm gonna like declare what my pipeline looks like. I'm gonna embed it in my source control repo, and the world is going to get better. And so like Palantir moved in this direction. We first adopted Travis CI and then in Circle CI. And
Yep.
like the world definitely gets better. It's like your CI step is at least like understandable for the first time. And that was great. But then I think over time, what we found, even for continuous integration, is like, especially if you're sort of trying to build modern software architectures, like oriented architectures, microservices, whatever. When we first started building Foundry, it started small with like 4 services, and then today it's a whole bunch. And the way you get your CI pipeline is, well, you clone the repo that you last worked on because you're familiar with
Yep.
that pipeline. You copy paste it, you make some changes, and now you have your new pipeline. And if you just do that, like sort of like over and over again over the course of many years, you end up with like just like massive like divergence across these pipelines, and
Yep.
it becomes like really expensive from an engineering standpoint to maintain these things, to onboard new people. And so I think a lot of engineering companies, what they do is they end up just basically forming, a developer experience team or a platform engineering team, and
Yep.
that team is responsible for like managing the complexity of having all these pipelines. So somewhere along the way, I think, code deployments started off as, well, I'm just going to like add a line to the end of my CI pipeline, which is going to publish my artifact to an artifactory or to container registry, which was great. Now I have like this immutable thing. And then, at some point they're like, great, now I'm going to deploy that thing. So I'm just going to add another line to my CI pipeline, which is like kube control apply and then
Yeah. Yeah.
deployment. And I think that's what a lot of people's like current take on, how you do CI CD today is. It's just like these basically the logical extension of your continuous integration framework, pipeline, toolkit, and so forth.
I would probably add to that too that there's a lot of half-baked concepts that wind up getting put in there, like how to do a canary deployment on AWS. Like
Oh
there,
yeah.
people will try and interpret what that means in like 15 different ways, and none of
Yes.
them are correct. And you often get builds stepped on, and you're not considering like how long do you have to monitor that thing before you decide whether or not to roll it out. And AWS doesn't exactly make the whole process super easy when you're dealing with a lot of these workloads. Like it's easier in Lambda, like they kind of have thought of that as a forethought, but like in many cases it feels as a developer like they didn't even have that as an afterthought. Like how are you going to manage these things?
Yeah.
So
Yeah.
it's been very challenging, I think.
It's been interesting watching the like engineering organizational design evolve
Right.
towards like small teams, microservices move independently, but the like tech tooling landscape not evolve in the same direction, because even
There's been
these
a
tools, it's
huge,
like,
oh yeah, huge backlash to that, by the way. Like there, I don't know if you've seen it, but like a lot of companies have been struggling so much to make that work because of the amount of orchestration involved when you have a
yeah,
microservice mesh, like trying to figure out how to deploy it all, that like a lot of teams have just said, forget it, man. We're going back to like distributed
yeah,
monoliths or like monoliths generally.
well, I think that's what basically people couldn't figure out how to make the deployment stuff
Yep.
work. And so what they did is they have a bunch of independent teams shipping a monolith. It's
Yep.
like in like maybe you get down to release trains that run every day or something, but like most people couldn't really engage with the complexity of that. So, and
Yeah.
that was one of the things Apollo tried to address from the very beginning. It's like, well, how do we enable continuous deployments, but for modern software architectures, such that we could realize the value of having small teams building independent services and enable them to release their service as often as they want without having to be like deadlocked on either a platform release that's going to take a month to do, or a release train where you're really not in control of the release process. And so Apollo is very much geared towards how do you solve that problem, instead
Yep.
of just ending up with your distributed monolith.
So what I see in that solution space though is like what you're enabling beyond just the workloads you've decided to run there, because but probably by solving for the Foundry workloads, like you had so many categories of problems in there you had to deal with. Like it's a very complex system. You have lots of dependencies, every environment, right? Like even environments people don't traditionally deploy to. Correct me if I'm wrong, but you probably also deployed environments where there's no internet access. Like there's
Yep.
you have a lot of complexity under there. So you solved this incredibly complex space. And by doing so, I think what you're really doing too is like what I've heard kind of described as the sky compute layer, but you guys generally refer to as like heterogeneous compute environments. But it's like that abstraction layer over what you're deploying to, so you don't have to write code that's like specific to one environment. You
Yep.
can write code that's going to run anywhere. But if you could talk a little bit about how Apollo enables that heterogeneous compute environment and like how you guys stumbled into that generally.
Yeah, absolutely. So I think, Palantir's deployment model from the very early days began as like us deploying software into, initially classified on-prem environments, then commercial on-prem environments, then single-tenant cloud environments, and then eventually multi-tenant cloud environments. And so for us, it was always very important to enable our developers a way of building software that could be deployed anywhere, like where you weren't like, and sort of, the generic version of this was uh, before we started Apollo, there was like a 57 step run book for how to install
Oh
some of
my
our stuff,
God,
and it
bro.
was just like, and a lot of it, you're like, well, why do I really need to know the URI of my dependent service? Like, why can't you just tell me that? Like, why do I really need to like type a command on a keyboard to generate a certificate so I can configure TLS,
Right,
HTTP? And so those were the set of problems that Apollo really tackled up front. It's like, how do you make it so that software deployment is a repeatable process without human involvement? And
right.
so there's a deployment platform was the first thing we built, basically like a software control plane that we run in each environment we want to deploy software in, that sort of solves for a lot of those mundane tasks of like, there's service discovery. So you can say, I just want to
Yep,
find the URI of this service. I don't know where it's running, but certainly the system does. Certificate generation. So that, like I know I need certs and a CA to be able to configure HTTPS, but I don't need to know how to get those things. The system can do that for me. So
yep,
there's a bunch of these features that we built in that enabled software developers to have a much more repeatable deployment process, a way of packaging, configuring their software, so they can take advantage of the deployment platform running in each of these environments to make the process more repeatable. So we started with that, and then you enable a developer to encode the set of dependencies they have. So if you need to ensure that you have your database and you need to ensure you have your authentication authorizations service, you can say that. You can encode the API version ranges inside of your product. So I need at least version 2.1 up
yep.
until 3.x. And then a human shouldn't have to go do the manual checking on those things.
Exactly.
And so Apollo then takes those set of constraints and can solve for them in the act of making a decision on which version of a service should be running or whether an upgrade can or can't happen and so forth.
Yep. And what's interesting about that the way you explained it is like we have a lot of tools today that we try to glue together to make those things happen. We might be using like Istios or something, as like as a L7 proxy to control for some of those things. We might be like gluing together some other piece of technology for service discovery or a service catalog or whatever it is. But like, dude, there's so much undifferentiated heavy lifting that's happening among like 4 or 5 different infra teams to make that happen. And it's
Yeah,
happening all over every company. And usually you're only solving for one space. You're like,
yeah,
solving that problem for AWS, but like, how are
yep,
you solving it for GCP or Azure? And what I find is like, what that really means, like, is that you're really vendor locked to to the cloud provider that you've written that code for, because your
yep,
infrastructure can't run anywhere else. It's like,
yep,
and even if you're using Terraform, what I've seen is like, oh, there's still vendor. Most of the code is vendor specific.
yep,
It's not generic in any way. I mean, and then I'll hear horror stories of like some companies say, oh, well, what we do is we prohibit the use of any cloud native service, and then we force everyone to reinvent the wheel underneath with like open source tech or something worse, that stuff they've built internally. And then they're vendor locked to themselves forever.
yep,
So it's
yep.
like, and it's like, do you really want to be in that problem space? Like, is that the business you want to be in? Is like solving the same problem over and over and over again? It's like, to me, that's why I think Apollo is so underrated, is like people don't really understand the category of problems and how massive this challenge is. And like, by doing this, you're not vendor locked to AWS. Now you can start choosing where you want to run workloads. Like, makes way more
Totally.
sense in my opinion.
Totally.
So,
Yeah,
yeah.
and there's not many, at some point in a company's like life cycle, you get to this point where like having chosen one cloud vendor, it's like
Yep.
if you don't have the ability of negotiating a better deal with a cloud vendor, they're
Yeah.
just going to take advantage of you. And the
Yep.
only real way of having that leverage is by having a real threat of being able to move your workload to their competitor
Exactly.
on a dime. And so I
Yeah.
think even, it's reasonable for startups to start in a single cloud, but there's not many companies I know of today that aren't like aggressively looking at diversifying, either for stability reasons, because
Yep.
cloud providers are going down more often,
It's
or
true.
just from a price like leverage standpoint. So I think this becomes a real problem when in terms of how you build software, how you deploy it, how you operate it at scale, and so forth.
100%. I think companies need to wake up to the security posture and the threat for the infrastructure as a whole. I mean, AWS is a big target. Azure is a big target. Like all these companies are becoming
Yep.
very big targets. So let's move on to a little bit. I want to get into some of the Apollo specific features. And so, like one of the things that I want to talk about is this concept of the Apollo catalog and the registry and sort of like how they interact and what their roles are in Apollo. So can you
Yep.
describe that?
Yeah, definitely. So the Apollo catalog is intended to be sort of like the knowledge base of all the software that you have released that is like deployable across your production instances.
Yep.
And I think some people view their like artifact store, their container registry as that. And for us, there's this big difference between the place that you want to store like every binary or container image that your CI process may produce versus the stuff that is like production ready. And then there's a bunch of information that we found is really important for your deployment system to know about in the act of deploying. And so that is what the Apollo catalog is. It's a way of registering software releases that you want to be deployable in production, and then a way of managing the information about those releases that should be part of the decision-making process for deployment. So it's things like, what are the dependent services that you have? What versions do you need to exist? Schema versions, schema migrations that can help you achieve those versions, and also things like rollout strategies, like, being able to just say this version of my product or my service should have this, be a blue-green rollout strategy versus
Yep.
just a rolling update. And so the Apollo catalog is a way of managing all that information. It's what manages, if you know that you have a bad version, having the ability of recalling that version and specifying a roll-off strategy, being able to recall a version because, you ran it through a vulnerability scanner or a virus scanner, and like you realizing, old versions of container images are just like riddled with CVEs. So the Apollo catalog is what manages all that information. And for us and for Apollo, it acts as essentially the gate into your production environments that is independent of your artifact store or your container registry. And I think sort of the final point is like, final point on that, for us, like we don't want Apollo to get in the way of your natural like software development process. And so, we have a lot of teams that want to publish binaries or container images of basically every commit on develop. And well, we definitely don't want every commit on develop being runnable in production. And so having
Right.
a layer that is different from your artifact store that governs like what is deployable in production has been a really important part of us managing both quality and security across our production environments.
Nice, nice. And one of the things I want to, if you see me looking over here, it's just because that's where my questions and notes are. So like just
Please.
as a heads up, that's what I'm looking at. Um, so as far as like this concept of, I heard you say develop in there, and I had a question later that I was going to ask, but like, are you opinionated at all about like the branching strategy you're using, or is like, does it matter, or like, do you do trunk-based
No,
development too, or?
I think most of our teams do. I say most of our teams. I maybe not be close enough to the details now, but I think most of our
Yep.
teams do um, like uh, like feature releases on branches, merged into develop, release off of develop. Um, some do like weekly releases or monthly releases where develop is like the active working version, and they like branch those into release versions. I think different teams have sort of played around with different branching strategies and models over time. Apollo is pretty unopinionated about it.
Awesome.
We really you sort of think of Apollo as picking up where CI leaves off. And
Yep.
so the integration point is, when you as a team are ready to like release a version of your software that you want to be managed by Apollo, the last thing you do is just make an API call to Apollo's catalog, essentially announcing the new version and telling us where it's at. And then from there, Apollo will like include that in the catalog and make it deployable. And so like how you get to that point, what branch of it's on is sort of like uh, not relevant detail in terms of Apollo
Cool.
as long as it knows where the artifact is.
That's cool. That's cool that you sort of teased that out because in a traditional CI/CD system, it's heavily dependent, like you actually have to build your workflows directly tied to that and centralized
Yep,
in your CI/CD system. It becomes problematic too when you go like, oh, what should be the trigger to actually promote this thing? It's
yep,
like, and
totally.
often it turns out to be a human. And so because you
Yep,
formalize like an actual process to say, hey, this is what determines how and when it gets released as an API caller, and that's probably formalized in some kind of specification. I think that's really smart in like teasing those things out for sure because it solves some of the problems that we've seen there. So moving on to like the org. So I really wanted to spend some time talking about the orchestration engine. I find that like super fascinating and sort of how it works with the catalog. But the first question I have about is that I read this statement that you, basically it computes the updates and actions that need to take place. So between the orchestration engine is working with the catalog to compute what needs to happen. And the first question I have is just like, how does it do that? Like, what
Yeah,
exactly is that?
yeah, it's a great question. So you could sort of think of like the main the main loop in the orchestration engine as resembling like a Kubernetes operator.
Okay.
Um, we have so we run an agent in each of the environments that you're going to manage software, that Apollo is going to manage software in. And one of the things it does is report back the sort of like last known state of the set of managed services or managed entities you're running. And so that's things like what version is this product on or this service on? Is it liveness, readiness, and health? And then some amount of like the state of the configuration that's currently running. And so that gets reported back to what we call the Apollo Hub, which is where the orchestration engine lives. It's where the software catalog lives. And that sort of amounts to like your observed state. Um, Whoever's responsible for the environments that you want to manage software in, whether that's the developers themselves, whether that's like, SRE folks or platform engineering people, um, they've defined the set of services they want to be managed in a given environment, and they've subscribed it to a release channel. And then from there, those things amount to what is like the declared or target state. And really all the orchestrator is doing is like looking at the target state, looking at the observed state, and then trying to figure out whether there's anything new that it can do. And so it's looking at the software catalog, looking for like, okay, I have these 10 different products, and these products have these different versions that exist on the release channel I'm using. And um, and okay, well, of these 10 products, two of them have new versions. Am I able to actually upgrade one of those two products to a new version, dependent based on the set of service dependencies declared by the products, any like change maintenance windows that might be configured, and so forth. And it basically computes the set of constraints that exist, um, filters down to the set of changes it can recommend. Everything from like, is there an upgrade? Do I need to roll off of an existing version because it was recalled? Is there a configuration change? And so forth. And then it has a way of sort of prioritizing all of the changes that make it to the bottom of the funnel, and then issues those changes to the Apollo agent running in each of these environments as a sort of suggested declarative state. So which is like I could issue you like a change version plan that changes the version of some service from version 1.12 to 1.14, for instance. And then from there, the Apollo agent's responsible for orchestrating that within the environment.
Does it need to know all of the versions specifically? So in the target state that I want to get to, do I, as the developer, have to define all of the dependencies that need to be updated? Or does the orchestration system also decide like, oh, there's a minor update here that includes a security patch or something. So I'm going to roll that in despite it not being part of this planned update or this target state.
Yeah, so as an application developer, you're going to include the dependent products and the
Yep.
version ranges of those products that you support. And
Yep.
so this tends to look like API boundaries, right? It's like, well, I support 2.x to 3.x of my service.
Yep.
And so as long as I can find Apollo can find the dependent service in that version range, it satisfies the constraint and can move forward and doesn't have to do anything else. When you are releasing a bunch of services in rapid succession, you do end up with this world where it's like, you actually can't upgrade one service until its dependency is upgraded and so forth. Um, and, uh, and sort of like it's a system that will like eventually converge to the right thing. In
Okay.
terms of prioritization of like, oh, I don't need to upgrade like this dependent service, but there is a security fix in there. There, this isn't like that decision isn't something that happens in the context of my upgrade.
Okay.
The minor version update for the security fix will get orchestrated through Apollo on its own right, though.
Okay. Cool. All right. And then the next thing I wanted to ask for is like, is this computation that takes place, is it like a heuristic or is this really a problem you've solved generally by just the way in which you describe all the artifacts that make up this system? So it's like you'd be unopinionated provided you ship the software in a format that Apollo can understand, but I could do anything, and it could run any workload there. I wouldn't necessarily be stuck with like, oh, it works up until this point, like there was a category of software I can't do that with.
Yeah, so Apollo thinks of the world in terms of like different like product types or entity types,
Okay.
where an entity type might be a Helm chart, or an entity type might be a witchcraft service, which is sort of like
Okay.
Palantir's like highly opinionated service model, or it might be a daemon set.
Yep.
And what in the different entity types influence the different types of constraints that apply when the orchestrator is trying to make a decision on how change can happen.
Okay.
And so, as an example, if you, for a daemon set, you may not care about quorum because you're going to run one replica on every host in the cluster, regardless of whether one of them is down or not. And so that may
Okay.
influence your ability to like upgrade a daemon set if one of the replicas
Right.
is unhealthy. Um, and so, you as an application developer, you have to sort of choose which entity type you want to deploy, and that will influence some about the way in which you package it. So a Helm chart, it's a Helm chart. You need the Helm chart files.
Yep.
Um, and then it will influence some about the set of constraints that apply during the computation. But beyond that, it's sort of up to you.
Okay.
Over time, and then Apollo's architecture is built such that we can expand the set of entity types or product types over time, where we can introduce a new type, you sort of will be able to define the set of constraints that apply, and then either Palantir or a customer can build their own agent that's responsible for orchestrating that like workload type in the environment you want to
Yep.
deploy it in. So as an example, you can imagine a world where like someone's like really all in on AWS Lambdas.
Yep.
Today, Apollo doesn't offer that, but it's easy to imagine a world where you're building an agent for Lambdas that's capable of like, doing the brokering between Apollo hubs
Yep.
and like AWS's Lambda APIs. And so
Yep.
those are the kinds of like expansions of workload types we expect to see in the future.
Yeah, but I mean, Foundry has an equivalent, in my opinion. I don't know. I would be, I would be wondering why a customer running Foundry might want to use Lambda when they have an equivalent that's better.
Well, I agree with that, but like we're sort of
Yep.
looking at Apollo as like having a much broader like total addressable market than Foundry does. 'Cause, it's like
Yeah, for sure.
uh, yeah.
Yeah, it's interesting because the types of entities you described, I think I could run just about any container-based workload I'm thinking of that I run today on AWS. I can't really think of anything that wouldn't fall into that category. So that's really cool, like really cool. And it's neat that you guys are already thinking about like, okay, serverless and other types of entities. The only weird thing about serverless is like it's really bizarre how it's described and deployed depending on who you're deploying it with. And
Yes.
so yeah, let me jump into some more questions here. So we touched on this a little bit, but what are the types of deployments that Apollo can support? I know you mentioned Canary deployments at one point, rolling updates, blue green.
Yep. Yeah. So there's a couple of versions. So it supports blue green out of the box. We have sort of like the standard Kubernetes style of rolling updates, like whatever like the sort of first class controllers give you out of the box. We also have sort of a higher order like health aware rolling upgrade. So Apollo
Yep.
has this notion of health checks, which developers can opt into. It's a way of essentially presenting a REST endpoint which describes the health of that given replica. And then we can use that as a way for doing, you could sort of, depending on what your definition of blue green is, it's sort of a way of doing like a fast blue green. So as long as the health of my endpoint comes up green, I will just move on to the next replica. And that's been really effective. So we use that a lot internally as well. So it's those are what we support today. And then over time, we expect to do more advanced rollout strategies around like traffic shaping through service meshes and so forth as well.
Nice, nice. Yeah, so like this is an interesting problem that you guys are solving by providing all these. And if you do get to the point where you have more advanced strategies around like monitoring the network, as opposed to like that's where I see like, oh, we can get rid of staging, because it's like really like
Yep.
I don't like maintaining a staging environment. Like distributed systems are complex by nature. They're really the only way you know as you interact with the system. You can't actually
Yep.
predict what will happen, which makes staging kind of pointless because it's just a different environment,
Yep.
So it's like,
Yep.
but if you can monitor the network health and know when something's unhealthy after you've
Yep.
deployed it, like that's what you want. You want that
Yep.
immediate feedback as fast as possible. So that I would love to see. Like that would be, and also, I mean, with Canary deployments, you can do that. You can do that with your other strategies you mentioned as well. So roll, and you said you do have a rollback strategy in there. You had talked about it
Yeah,
briefly, right?
absolutely.
Can
Yeah.
you talk a
So,
little bit about that? Yep.
yeah. So, Apollo will automatically, if you like choose a blue green, for instance, if the green version starts failing, Apollo will automatically roll you back to the original version. The same thing is
Nice.
true for like a healthware rolling update.
Yep.
And then it will essentially like, recall the version that failed the upgrade on to basically prevent other sort of instances of that service upgrading to it across your fleet until you've had, a human's had a chance to go and investigate. There are certainly scenarios, excuse me, certain scenarios that like rolling back is really not the thing you want to do. Schema migrations are the thing that immediately comes to mind. It's like if
Right.
one of your services you upgrade, and the act of upgrading you also migrated the schema, rolling back to the previous version isn't able to read the new database schema, really puts you in a bad spot. And so Apollo tries to make intelligent decisions when it's
Right.
doing rollbacks. Same thing is true for dependent services. Like it's pretty common if you are releasing a lot of software very quickly,
Right.
you can find yourself in a position where you upgraded service A. Service B had a dependency on the new version of service A, so service B upgrades, and now service A is having issues. It should roll back, but you can't roll service A back because service B is now pegged to the minimum version of service A. So there are these issues that do come with the complexities of doing continuous deployment of like service-oriented architectures.
Yep.
But Apollo tries to automate as much of this as possible, where it's not able to like roll you back, like raise a red flag and help you as a human understand the complexity of what's happening, so you can make like the intelligent decision on your own.
Yeah, that's I mean at every organization I've been at, that's a human problem. Most of they don't even have this complexity of saying like here's your problem. You know,
Yeah,
like you're responding to reports that a system is out, or like
yeah.
you have a bug report that's totally unrelated to the underlying cause. You're trying to figure out what happened. But that also brings me to the point like what kind of like debugging tools does Apollo give the developer to help with that problem?
Yeah, we built out a lot of these things over time, and so we have a pretty deep integration with observability platforms. We aren't trying to be our own. We're not trying to compete with the Datadogs of the world, but it will integrate with your observability platform. It will, and when I mean integrate, if you're running a like a central observability platform,
Yep.
you can either send metrics, collect metrics yourself from your services, send them to your central place yourself, or we have the plumbing that allows that to happen. Collect metrics from all these like spoke environments, send them through the Apollo Hub, and then the Apollo Hub can send them on to the observability platform your DevOps folks, your SREs are using. Same thing for logs. We offer like an out of the box log aggregation system, Elk Stack. But also,
Yep.
if you have something else you're looking at using, like we don't want to get in your way. Like that's not an opinion we're going to force on you.
I want
And
to
so
use
that helps.
Foundry, man. Foundry for that stuff. That's what we're doing right now as part of our
Yeah,
the proof of concept we're building is a telemetry
good for
system
you
on
guys.
Foundry. Yeah, yeah,
That's
for sure.
awesome.
Yeah, yeah.
And then, so that helps with like the observability piece.
Yep.
Like it helps us like automatically wire up monitors for services that Apollo is managing and maintain those monitors and how the monitors change with new versions as well. But then what we found is, there's just a bunch of stuff that when there is an incident, oftentimes your developer just needs more information than they currently have access to. And so over time, we built out a pretty cool set of features that allow developers to proactively collect diagnostic information. So you can say collect a Java flight recorder session from a live Java process, or you can collect Go
That's cool.
pprops, whether it's like CPU profiles or memory
Nice.
profiles and so forth. Like grab stack traces and pull that back all through the UI, so your developers don't have to have SSH access to these environments or anything like that. And so we built a bunch of
That's
those things
really cool,
out.
man. That's
Yeah,
really cool. Like we have a lot of issues when it comes to production access, and like we
yeah,
want to give developers that kind of access, but it's very difficult to stay compliant and do
totally,
it. That's
totally.
cool,
I
man.
mean,
Really cool.
yeah, and, like for us, we operate in hundreds of production environments, and we're not
Yep.
giving our developers access to those. And so for
Yep.
us, it was this challenge of how do you enable SaaS-like control over the software, but without having developers have access to these places. These environments are highly regulated, like have to things like FedRAMP or IL5 environments, and so
Nice.
we built out these tools that allow them to get the information they need without having someone stand in their way, but also without giving them access. And it's been a huge productivity boost for them in terms of like
Dude,
their ability to like both build better software because they
that's
have
cool.
better information, but also remediate incidences.
I mean, man, if you can bring InfoSec and developers together and they're all happy,
Yeah,
like woohoo, like that's a
totally.
huge win. Yeah.
Yeah,
Nice
totally.
work, dude. Nice work. Let me talk a little bit too about software bill of materials because this is a big topic at our work right now. And we're kind of drifting into InfoSec a little bit. But like S bombs are like we're really trying to tackle the problem. But when I read that Apollo provides some of that out of the box, like can you talk a little bit about how deep it can go into producing S bombs and like do you still have to manually find other tools to fill in the gaps or what's it like?
Yeah, so it's a great question. We also have been putting a bunch of work within Palantir into, doing real like software supply chain enforcement
Yeah.
across our development environments. So, and that's why I'm playing an important role in that. Apollo, like a lot of the other stuff, like we're not trying to solve every problem out there. What we're trying to
Yep.
do is make sure those, like, where there are tools that solve problems really well, that they integrate seamlessly into the rest of the platform. And so same thing for like security scanners, virus scanners. Like we want, the Apollo catalog because it sits on, sort of like to the right of your artifact store, but to the left of your production environments,
Yep.
provides a really great place to actually generate, like use those tools that are like, very custom, or it's not custom, very specific towards building SBOMs. Use
Yep.
those tools to build SBOMs as you're registering the product to the software catalog. So you can either produce your own SBOM included in the sort of Apollo payload you're going to register with the catalog, or we're building integration that will catch the registration event of that product and then run it through like open source or commercial tools that generate SBOMs for you, so that you don't have to like go run around, do that,
Oh
figure out how
yeah.
to integrate that with your
That's
CI
awesome.
process, but you still get the
Yep.
benefit of all of it.
Yeah. No, that's great. That's a huge step forward from what we've been kind of doing now. It's a really distributed process now, and we like put a lot of onus on
Yep,
the teams to figure out how they're going to produce it. But that
totally.
leads to like t teams using different tools or figuring out different
Yeah,
like what does that mean to this team? What does that mean to so like we're really trying to standardize like a standard way of getting them, in a
yeah,
standard format. And can we can show compliance, like
yep.
verify that it's actually that we are compliant. So that's really cool. And then I think are we at time? Where are we at on time?
We're about
We're
at
happy to
time.
keep going.
Yeah, we can keep going for probably
Awesome.
another 5, 10 minutes.
Awesome. All right, cool. So one of the things I want you to try and describe is like what's like a typical day-to-day operator experience like using Apollo? Like what's that like?
Yeah, I think it's a great question. I think it depends on what your role is in your production management story. And so if you're a DevOps person, you're building software, you're operating it, I think, the things you care about and things that you look at on a daily basis are different than if you're an SRE or, a production engineer responsible for ensuring like a whole environment is up and running correctly. And so for a developer, Apollo really tries to orient you towards like making sure that like you understand that, sorry, my cat,
No
making
worries.
sure you understand that like this, your job does not end once your code merges, right? And there's a lot of work that comes after that. And so everything from like ensuring that like new versions that your team's responsible for sort of like make it all the way across your fleet, like actually roll out across release channels, get into
Yep.
your production environments, making sure that like there are no monitors firing, and when they do fire, you have the ability of like going and investigating what's happening and remediating any issues as soon as possible. But otherwise, like if everything is going well, like we don't want you spending a lot of time looking at dashboards, looking at like screens. You should be writing code.
Yep.
Um, and so like, Apollo tries to orient like developers in that way. But at the same time, it's like, if you're a platform engineer, if you're a production engineer, SRE type, you're responsible for all the software running in a given environment. You're probably looking at different things. You may be looking at, okay, like what, do I have upgrades that are blocked? Do I have, product versions that have been recalled that for various reasons can't be rolled back without human intervention? And like, being more on top of things like change requests, making sure
Yep.
that, as people want to make changes, those things are being reviewed appropriately. You're meeting your own SLAs, and then just like the general health of the software you're responsible for. And I think the goal is to same thing. Like we don't want you having to stare at 100 different dashboards to understand the health of the stuff you're responsible for. That should be an easy part of your job, and it should be
Yep.
easy to route your attention as things turn red.
That's awesome. And like it hit in there let's unpack that a little bit because like you said some things in there that make me realize like, oh, this was geared towards developers. You're not targeting like, DevOps or something like that. It's really there was software engineers' responsibility to manage their deployments, fix things when they break. Am I reading into that too much or is that true?
I think that is true, but it's not specific to that, I would say.
Yeah.
So like at Palantir, like we built Apollo for both for both paradigms.
Perfect.
I think we right as we were really rolling out Apollo, moved the whole company towards a DevOps model to where
Yep.
developers who are building software are also responsible for ensuring the health of that software in the unclassified commercial fleet.
Well, no, but
We
now
also,
you're using the term DevOps appropriately. I can't let you do that because like it's not.
I know
It's a joke.
it's very
It's a
off putting.
joke. Yeah. You're actually using the term correctly. What it means today in most places is like there's this other team that aren't the software
Yeah,
engineers, and we call that
yeah.
DevOps. So that's
No, it's like,
yeah.
yeah. We do have on-premise environments where the developers don't have access. We have
Yep.
classified environments that developers don't have access, where you end up with a more, like, I would say, classic version of like SREs and production
Yep.
engineers who are responsible for the entire environment. And so we built Apollo to really account for both of those because we have both of those versions. And I think most organizations that we talk to today aren't all in one camp or the other camp. They're somewhere in
Yep.
between, and that may be like by design, or they may be in some transition phase. And we think Apollo is like well geared towards solving for sort of anyone on that spectrum.
Oh yeah. No, I think every organization has both for sure. Like I haven't seen one that doesn't kind of have both of those models. I think it's just been hard. Like at a lot of companies, they struggle with figuring out like how do they get out of the one paradigm and actually have like true
Yeah,
DevOps with their software engineers and then give them a platform that actually is achievable because you can't have a software team that's made up of all senior engineers. It's like
yeah,
it's like it has to be a platform that's capable of empowering the L1s, the L2s, the L3s to also participate on, without having to like hot potato it over to the senior engineer.
totally.
So yeah, but
Yep.
it sounds like you have that as sort of a solved problem and that this platform sounds pretty awesome and pretty easy to use.
Yeah, I think it's certainly helped Palantir get to where we are today. And so, and if we look around every now and then, be like, is there anything we'd rather use than this? And like, we've come up blank in those inquiries. So we're pretty happy with Apollo, what it's done for us, and we're hopeful that it can do the same thing for other people.
Awesome. I think that's a good note to end on. That's awesome. And I,
Cool.
I I have to get this product in my hand one day. So Isabel,
Yeah.
you got a champion, Greg. You got a champion for me to get this product in my hands. It's so far I
Absolutely.
haven't had access. So.
We'd be happy to set up another deep dive where we can actually demo and get your hands on it as well in the
That would be
future.
so cool. Definitely. Well, thank you so much. I really appreciate Isabel for you hooking all this up. And Greg, this is an awesome interview, man. And I think my audience is going to freak out. Definitely going to be more on the technical side, but I have like a bunch of engineers who are hitting me up about this right now. So I
Cool.
think they're going to love it. Yeah.
Awesome. Well, thanks so
Cool.
much for the time. We appreciate it.
Totally. Talk to you and good luck at demo day. I'm pumping it up on the
Hey,
channel.
yeah, let us know if you have any feedback following. I'll hit you up.
For sure. I'll totally give you feedback and cover it for sure.
Awesome.
Awesome. All right.
Great to see
Thank
you
you,
again,
everyone.
Ryan.
Great to see you too. Bye. There you have it, ladies and gentlemen. A complete breakdown of Apollo. And I know many of you are still confused, but if you walk away from this interview with one thing, it's the statement that from Greg that we believe Apollo has a bigger TAM than Foundry. See you next time, people.